Hello students, today in our session on rest and motion on the kinematics portion, we'll be talking about freely falling bodies. So freely falling bodies is also important to understand from an exam point of view. So freely falling bodies is also an example of motion in a straight line. So the assumptions that we need to make to assure that the freely falling body is a motion in a straight line is that we neglect air resistance. And we also assume another thing, that the particle or the object is dropped from a height towards the Earth's surface, and that height is very much less than the radius of the Earth. So, or we can say that the object is dropped from a point which is very close to the surface of the Earth. So these are the assumptions that we need to make for simplicity of solving the problem. So the first assumption is that we neglect air resistance, and the second assumption is that we drop the particle or the object from the height which is very close to the Earth's surface. So these are the assumptions that we need to make. So now if we consider, we normally by convention we consider the positive. It seems I'm unable to draw a straight line very properly. So anyways, let us try once again. So this is the positive y-axis and this is the x-axis. So now we normally assume that when we assume that the positive y-axis is along this side. So now our acceleration due to gravity, another thing that we need to keep in mind is that the acceleration due to gravity. So this is equal to, we are denoting it by g, and the value of this g is normally 9.8 meter per second square, or it is also equal to 32 feet per second square. 32 feet. So this 9.8 meter per second square is basically in SI units, and 32 feet per second square we normally use it in FPS units. So these are the things that you need to keep in mind. So this is acceleration due to gravity. Now this acceleration due to gravity is always directed towards the center of the Earth. This acceleration due to gravity, let me write it down, this is always directed to the center of the Earth. So as you can see, the acceleration due to gravity will be always directed downwards, and we are considering our positive y-axis in the upward direction. Basically by y-axis is positive, we mean the upward direction, and the g is in the downward direction. So as you can see, the g and suppose we are throwing a stone from the ground upwards, then its motion is in opposite direction to the acceleration due to gravity. This is the thing that you need to remember. So now we already know that the equations of motion are given by v is equal to u plus at, and then we have x is equal to ut plus half of at square, and then we have another equation of motion, which is that v square is equal to u square plus twice of ax. So these are the three equations of motion. Now for a freely falling body, these things are little bit changed. These equations change a little bit. So if suppose we have a body over here, object over here, and then we are throwing it with the initial velocity, suppose u, and then it reaches some point, suppose h, after time t, and the velocity at this point will be v. Okay, and the time taken in this part will be t, and we know that the acceleration due to gravity g is always directed downwards. So this is the scenario that we need to keep in mind. So in this case, as you can see, the entire scenario will be replaced by, here v will be equal to u, and the acceleration is a is equal to minus g, since it is directed in the opposite direction to the motion. So this will be v is equal to u minus gt, or in other case the velocity will decrease as the body goes outwards. This is the first equation of motion for a freely falling body. The second equation is that x is equal to ut plus half of at square. Here the x is replaced in freely falling bodies, it is replaced by h, where h is the height, and this is equal to ut, and again half of this a will be replaced by minus g, and this will be equal to ut minus half of gt square. And then our next third equation of motion is that v square is equal to u square plus twice ax rather. So here a becomes minus g and x becomes h. So this will give us that v square is equal to u square minus 2gh. So these are the equations of motion for a freely falling body. So these are the things that you need to keep in mind. So as you can see, our consideration of the direction of g and the y-axis being positive in the upward direction has resulted in this equations of motion. Now, had we taken the y-axis to be positive in the downward direction, in that case g and the y-axis would have the same direction. So in that case, the g that we put minus sign over here, that would not have been the case, and we would have replaced it by plus g. In that case, v would have been equal to u plus gt. But normally this is the established convention that we normally use. Maybe you need to use that convention where you suppose that y is positive in the downward direction in some numericals or sums. But in normal convention, we always go with this convention where g is going in the downward direction and y-axis is positive in the upward direction. So this is what we consider. So let us try to solve a sum, or let me try to give you a sum so that you can understand more clearly that what is happening over here. Let me rub it out. So suppose we are given a body is over here, and the body is thrown upwards with an initial speed velocity of u meter per second square, and then we need to calculate the maximum height that it will reach. So the maximum height, let it be given by h max, the maximum height that it will reach after which it will fall down. So we need to find out this h max. This is what we need to find out. This is a fairly easy problem. So what happens at the maximum height? At the maximum height, basically your velocity becomes zero. So this will be given by v will be equal to u minus gt. We know that this is the equation of motion for a freely falling body, and in this case, as you know, this is the equation of motion. So now here the final velocity is equal to 0, and this is equal to u, and this is equal to gt. So the time taken to reach that maximum height will be equal to u by g. This is the maximum height. So therefore now if we write that, we know that v square is equal to u square minus twice g, and in that case here it will be h. So if we consider the maximum height, this will be equal to, v is basically equal to 0, so 0 square will be 0, u square minus twice g, and this will be h max. So this will give us that h max will be equal to u square by twice g. So if we throw a particle with a velocity u in the upward direction, then the maximum height that it will reach is u square by twice g. This is the answer. And the portion that I was doing over here, this is basically the time taken to reach the maximum height. Now let us assume, let me continue the problem further, and let me find out the time taken for the particle to go up and then fall down, basically the time of flight. So now it has reached at the top point where it is v is equal to 0. Now it will again fall down and it will reach the earth with some velocity, suppose u dash, and we need to find out here it is time 1, time taken is t1, and here let the time be equal to t2. So this is the time that we are considering. So now we have already found out t1. So this is basically the t1 that we are considering. Now let us consider the time taken to come down. So t2 will be equal to, now for t2 basically the initial velocity we know that v is equal to u minus gt. So in this case, as you can see, the velocity, the direction of motion and the velocity will be in the same direction. So here this will be plus gt in this case. So this will give us, now initial velocity is 0, final velocity we have shown as u dash, and u dash is equal to 0 plus g into, and t is here t2. So this gives us that t2 is equal to u dash by g. This is what we know. And also another thing that you need to keep in mind that here the distance traveled is h max. So now v square is equal to u square plus twice g h max. So here initial velocity, since it started from this point, this is 0 square, and v dash we have already found out as u dash square, and this is equal to twice gh max. Twice gh max is basically equal to u square, and that will give us that u dash square is equal to u square, and that will give us that u dash is equal to u. So the final velocity is equal to the initial velocity with which it was thrown up. So that is what we have found out. So that will imply that t2 will be equal to u by g. So therefore that will give us the total time of travel, which will be equal to t1 plus t2, and both of them are equal. They are both equal to u by g. So this will be equal to twice u by g, and this is the time of flight. So these are the various things that you need to remember for a freely falling body. So basically, freely falling bodies are motions in a straight line, and you need to assume the convention for the direction of g and the y-axis being upward and downward. And these are the equations of motion that you need to remember, where v is equal to u minus gt, h is equal to ut minus half gt square, and b square is equal to u square plus twice gs. And the thing that we are considering is the body is going upwards. These are the things that you need to consider. So we'll be talking more about projectile motion in our next video. So till then, all the best for your upcoming examinations. And in case you have any doubt, then you can comment in the comment section below, and we'll try to get back to you. Thank you very much.